Hi, this is Fazana again. Welcome to another topic on the Fazmaths channel. Please watch my video on the connection between linear sequences and linear graphs before watching this video. In this part 1, we'll cover the basic concepts of the equation of a straight line, how to plot the line graph, how to determine the equation of a line from the graph, and how to substitute the coordinates of a point to find the y-intercept where you already know the gradient. Let's have a look. Okay, so the equation of a straight line is y equals mx plus c. M is the gradient, which is your change in y divided by your change in x. And c is your y-intercept. Your gradient just measures the steepness of a line. So the steeper it is, the higher the gradient. So this could be y equals 2x, whereas this one would be y equals 4x. If you've actually watched the video on the connection between the straight line graph and the nth term, when you're plotting a line, the y equals 2x plus 3, so the mx plus c is the same as the nth term, which is an plus c. So you can actually use the nth term to plot the line. So the 0th term would be 3. And then with the nth term, the difference in your numbers is 2. So you go plus 2, plus 2, plus 2. So you've got 5, plus 2 is 7, plus 2 is 9. And when you're going that way, you're minusing 2. So 3 minus 2 is 1, 1 minus 2 is minus 1, and minus 1 minus 2 is minus 3. Okay, so that's how to plot it. And it's so easy, rather than substituting, going 2 times minus 3 is minus 6, plus 3 is minus 3. You just use the nth term to plot. So if we actually sketch this, these points, we can see the straight line. Okay, and there you go. There's your y equals 2x plus 3. And you can see all the points that we've sketched. Okay, let's try another one, just to show how easy it is to plot the straight line. So here we've been asked to plot y equals minus 3x plus 1. So you can tell your 0th term is plus 1. And then your difference in your numbers is minus 3. So you're going 1 minus 3 that way. So you have minus 2. Minus 3 is minus 5, and minus 3 is minus 8. Whereas if you're going that way, you're adding 3. So 1 plus 3 is 4, plus 3 is 7, plus 3 is 10. Okay? And again, if you sketch it, you can tell you've got the line y equals minus 3x plus 1. Just one thing to remember. If a line is going that way, then it's going to have a positive gradient, which we'll discuss on the next slide, but just to show it to you this way. And if a line is drawn that way, then it's got a negative gradient. And you can see we've got y equals minus 3x there. Yeah? Okay, so let's see, when we have the line, how to determine the equation. Okay, so when we're trying to determine the equation, I always just write y equals mx plus c, gives me a sense of direction. My gradient, what you do is you want to find out the steepness again. So you draw a triangle that way, and you know it is the change in y divided by your change in x. So it's going up 3, and it's going across 1. So m equals 3 divided by 1, which is 3. Always be really careful, because because you do 1 and 3 when you're drawing the triangle, it's so easy to take the 1 first. But remember, it's your change in y divided by your change in x. And again, when you're doing the nth term, you can see for every one pattern number, it goes up 3. Yeah? Okay, so the first part of your equation is y equals 3x. You know your c is your y-intercept, so it's where it cuts the y-axis, so it's at 0, 1. So you've got y equals 3x plus 1. Easy, isn't it? Yeah? Okay, let's find the equation of line B. Okay, this time, as I said in the previous graph, if a line is drawn that way, it's got a negative gradient. So again, you've got your y equals mx plus c. Your m is your change in y divided by your change in x. So we draw it that way, which is quite a simple one. Remember, you can't actually draw a triangle from a point that's not on the actual integer points. Yeah. So when we're drawing our triangle that way, you can see we're going x is getting less, so it's minus 1, 1. So again, it's your change in y, which is 1 divided by negative 1, which is just minus 1. So the first part of your equation, y equals minus x, and then again your c is your y-intercept. Where is it crossing the y-axis? At 2, so y equals minus x plus 2. Okay, all right. Now, one very important thing to remember is if you're not given the line and you're just given 2 points, and you have to find the gradient, then again, you know your m is your change in y divided by your change in x. Okay? And you know these are your x coordinates and these are your y coordinates. So the difference between 1 and 5, what is the change when it goes from 1 to 5, which is 4, divided by your change in x, so from 3 to 5 is 2, so your gradient is 2. Yeah? So you didn't really need a line drawn for that. Okay, again, change in y divided by your change in x, so from 7 to 9 it's 2, and from 4 to 10 it's 6, so your gradient is 1/3. Okay, and this one here, m equals change in y, so from 1 to 5 is 4, and from 6 to 2 is minus 4, so your gradient here is minus 1. Okay, all right, let's have a look at something a little different. Okay, here we have to find the equation of the straight line, where we're given the gradient and a point that actually lies on the line. So for A, we've got the gradient 3, so we know it's y equals 3x. Now, if that point lies on the line, then it has to satisfy that equation. So what you do is you substitute that point on the line. So you know that's your x coordinate and that's your y coordinate. So instead of y, you put 2. And let's just put the coordinate there so we don't make any mistakes. So you've got 2 equals 3 times your x coordinate. So 3 times 1 is 3. Now what do you do to 3 to get 2? Because you know this has to equal. So we minus 1. So our equation is y equals 3x minus 1. To satisfy the condition that that point has to lie on that line. Yeah, that was easy. Okay, let's try another one. So here we know y equals minus 1x, so just minus x. And then substitute that point 5, 3. So instead of y, we put 3. equals minus x, so minus 5. And what do we do to minus 5 to get 3? We add 8, so we've got the equation y equals minus x plus 8. Okay, let's try another one. So here we know it's y equals a third x. Okay, and the point is minus 3, 1. So instead of y, we write the 1 equals a third of minus 3. I'll put the minus first. I always write the minus first just so that it's not so overwhelming. And then a third of 3 is 1. And what do you do to minus 1 to get 1? Well, we'll add 2. So that's your equation. Okay, and finally, one more. Y equals minus 5, 6x. Oh, this one's a nice, interesting one. Okay, and then we substitute the point, 9 minus 2. So we'll put minus 2 equals, and again, I'll put the minus first. So we're doing 5/6 of 9. So 5/6 times 9. I hope you're okay with cross dividing. So 3 goes into there twice, 3 goes into there 3 times. So we've got 15 over 2, which is 7.5. So we've got minus 7.5. And what do we add to that to get minus 2? So we'll have to add 5.5. Okay, so that is your equation. That was all right, yes? The trick is just to substitute. Anytime you know the gradient and you want to find your y-intercept, as long as you've got a point on that line, you can substitute it. Okay, let's try this. Okay, we're trying to match the equation with the straight lines. So here we've got y equals 2x. Okay, as you can see, there is no y-intercept. So you know that it has to cross at the origin. So immediately we can say equation A relates to line S. Okay? And then what I've also noted is that that line is actually parallel to S. Now when two lines are parallel, it means they've got the same gradient because they have the same steepness. Yeah, so parallel lines, same gradient. Okay, so we just have to look for another equation that's got the 2 as the gradient. So you can see you've got y equals 2x plus 3. So line R must be equation C. Yeah, so we've done that line and that line. Okay, let's look at line P. So by knowing that equation C, which is line R, crosses it at 0, 3, and we know line P has got a negative gradient, you can tell it must be 3 minus 2x, because that's got a negative gradient and it still crosses the y-axis at 3. So that's line P. So that's done. And this line here is y equals 3, because every point on this line, the y coordinate will be 3. So you've got 1, 3, 2, 3, 3, 3, 4, 3, 5, 3. Okay, so that line is Q. All right, okay. So these are all the things to sort of look out for. All right. That's all for now. I hope that was helpful and easy to understand. Please join me in part 2 to find the equation of a straight line when you're only given the coordinates of 2 points on the line. Keep practicing and the subject matter will become so easy. Remember, you're in control. Until next time, take care. Bye.